Hello and welcome to my presentation about designing optimized hollow microneedles for minimally invasive exosome extraction. So what are exosomes? They are extracellular vesicles between 30 and 200 nanometers in diameter, and they're secreted from living cells containing a bunch of things including proteins, lipids, and nucleic acids. They have been the subject of a lot of research in recent years, and that has identified them as surrogates of cancer progression, meaning that cancerous cells secrete these vesicles and they contain biomarkers. So the point of this research is to create a diagnostic tool so that those biomarkers can be detected earlier than they normally are, which can lead to a decreased level in the number of deaths due to these cancers. A proposed method of doing this involves using microneedles, which are minimally invasive because they do not activate the pain receptors, which are deeper in the epidermis like hypodermic needles do, but they penetrate the skin layer and reside in the epidermis instead. So the objective of this work is to rationally design a platform for exosome uptake using hollow microneedles that have been printed in a 3D SLA printer. And there is a need for a sustainable, accessible point-of-care device. Sustainable, obviously meaning that it's not impacting future generations, it's conserving resources. Accessible, meaning it's low cost and available for all. And it's a point-of-care device because it is a single device that can detect the presence of cancerous biomarkers as opposed to needing further analysis in a lab. So in terms of optimization, this is required before printing to conserve resources. So instead of trying a trial and error method of printing these microneedles to see if they are deep enough, to see if they can deliver drugs, / if they can uptake this fluid which contains our exosome biomarkers, which is what we want. And we can use CAD or computer aided design coupled with a 3D printing technique because this allows for flexibility. So the results here you can see here is a CAD design of a 5x5 microneedle array with surface area of individual microneedles of 0.19 centimeters squared, radius 0.0145 centimeters, aspect ratio of 4, and a length of 700 micrometers. And the value of these parameters were optimized using a function best suited for skin permeability. And the work in the future would be to print these designs using a biocompatible resin in a printer like this, which is in 9West 4.01, the Formlabs Form 3, and to perform penetration tests to model skin to make sure that they are sharp enough, to investigate the uptake of a dye suspension containing polystyrene beads which model the exosomes, and then use techniques to confirm that these models have been taken up by those hollow microneedles, and then analyze them using 3D imagery techniques and perform mechanical resistance tests. Thank you very much for listening to my video.